We have decided to use both replication and randomization in our screening DOE. Replication, by providing multiple sets of data under identical conditions, will provide an estimate of experimental error, which will become the basis for determining if a difference in observations is significant or not. A lurking variable is a variable which has an important effect on outcomes, but which has not been accounted for in the data. In this case, we will randomize the order in which various experiments take place, so that a time-dependent lurking variable, possibly tied to when a particular activity takes place, does not pollute the results. The experimenter's checklist is an excellent resource. Click on Tell Me More to see a printable copy of this document. You can also find it in the Tools section from any of the screens. After taking all of these considerations into account, we decided how to address the situation in our commercial loan approval process. We will perform a screening DOE with a two-level full factorial design on the three remaining factors to identify the true vital X's. We will use both replication and randomization to enhance the reliability of our results. Click Next to continue. To summarize our design, we start out with three factors: the font size, the application type, and the use of required field flagging. We will define two possible levels for each factor. The font size will be either small or large. The application type will be either paper or electronic. And required fields will be either flagged or not flagged in the entry system. Click Next to continue. So how many different tests make up a full factorial? Before we discuss the underlying logic, let's see if you can figure it out. We have three factors and two levels we will use for each. So how many different tests do we have to run in order to cover all possible combinations? Each combination must contain a unique combination of values for all three factors. Select your answer and click on Done when you are ready to continue. There are 8 possible combinations of tests. We can look at this in a number of ways. Click Next and we'll go through the logic. Here are the 8 possible combinations which we will test in our screening DOE. If all our screening experiments were limited to 3 variables and 2 levels, it would be simple to determine the number of possible combinations. We realize, however, that in the real world, there are often far larger numbers of potential causes to test. Is there a simple mathematical formula which we can use to determine how many combinations there are for any number of factors? Click Next and we'll look at one. The general formula for the number of tests, or n, required for a full factorial DOE is n equals the number of levels to the power of the number of factors. Click Next to continue. If we apply the general formula to the commercial loan case, we have 2 levels for 3 factors. Taking 2 to the power of 3 results in 8 different tests. Click Next to continue. It would be valid to ask why we only test each factor at 2 levels. There are 2 answers to this question. First of all, we do so because this is a screening DOE rather than an optimization DOE. We are only attempting to verify the significance of the factor, not determine the optimal setting. If the factors are capable of multiple settings, the optimization DOE will require multiple levels. In this particular case, however, there are only 2 possible settings for the factors. There are only 2 font sizes available. The application is either paper or electronic, and the required fields are either flagged or not. So we won't be doing a separate optimization DOE for this case.
Next task is
Click
to design
Next
the
to
experiment.
continue. We're going to do a full factorial experiment as our screening exercise. All tests will be done at the same time to avoid any changes in experimental conditions. Actual loan applications will be chosen to represent the full range of experimental conditions. The data entry associates will not be aware that this experiment is in progress. We will do 2 replications of each set of conditions, which will provide a total of 16 data points. In order to perform the statistical analysis, we must utilize numbers to represent the levels for each factor. In this case, since each factor has 2 levels, we will code those levels as -1 and 1. Let's build a chart to show what we mean. For the font size, -1 will designate a small font, and 1 will designate a large one. For the application type, -1 will designate a paper form, and 1 will indicate an electronic form. Finally, -1 will indicate that the required fields are not highlighted, while 1 will indicate that they are. It's a good practice to make a note of how you have coded these levels because that information is not completely indicated in the Minitab results. Click Next and we'll look at the results of our experiments. The first step is to select your factorial design. First, click on the Stat menu and then select DOE. From the DOE submenu, select Create Factorial Design. Click Next to continue. This dialog box comes up when you select Create a Factorial Design. Since we have only 2 values, let's select 2-level factorial design with the default generators. We have 3 factors to address, so select 3 from the Number of Factors pull-down menu. We still have to select an actual design, so click on Designs. Click Next to continue. When you click on Designs, this dialog box appears. First, select Full Factorial from the choices in the large window. Make sure that number of center points is 0. Then select 2 for the number of replicates. In Minitab, this automatically requires each individual test to be run 2 times. Then make sure that the number of blocks is set to 1. After that, click on the OK button. Click Next to continue. When you click on OK, you will go back to the top design screen. Next, you need to name the 3 factors. To do this, click on Factors. Clicking on the Factors button brings up this dialog box. We're going to change the names and level identification here in order to make the results more easily understood. We will rename the 3 factors Font, App Type, and Field Highlighted. We will also rename the low and high levels for each factor to provide more descriptive information. When you have changed the names and labels for the 2 levels as shown here, click on the OK button. By default, Minitab is set to randomize the run order and to assume there is only 1 block. We're going to accept those defaults of the program, so the final step is clicking the OK button to accept the design. If you did everything right, you will see this information in the session window of Minitab. Factors 3 indicates that you have 3 variables. The base design shows that you have 3 variables and 8 unique tests, which is a full factorial design for this group. The Runs field says you have 16 actual tests to perform, while the Replicates field says that each of the 8 unique tests will be run twice. We aren't going to bother with blocks and center points in this example. The system then generates Click Next and we'll continue. Numbers in the first column represent the combinations of factors. The numbers in the second are the order of the run. You can see from these 2 columns that the runs have been randomized to avoid lurking variables. Since we are not using center points or blocks, all of the entries in those columns are 1. The last 3 columns indicate the actual level of each of the 3 variables. So if we look, for example, at row 4, we can see that it refers to the combination of large font size, an electronic form, and the required fields will not be flagged. Click Next to continue. So here are the results of all our tests. The actual number of missing data fields has been added as column C8. Our next step will be to analyze this data. Click Next to continue. Now that we have the data in place, it's time to analyze our factorial screening. From the Stat menu, select DOE, and then from the submenu, select Analyze Factorial Design. When you make your selection, the now familiar Minitab dialog box will appear. You select Missing Data Fields as your response by clicking on column C8 in the selection box, and then clicking on Select. When your dialog box looks like this, you should click on Terms to make sure that they are correct. A key item here is to determine which terms will be analyzed by Minitab. This is defined in the pull-down menu at the upper right. If one is selected, only the main effects or the individual variables in isolation will be analyzed. There will be no analysis of the interactions between variables. If 2 is selected, the two-way interactions between all pairs of variables will also be analyzed. The default is 3, which means that all interactions, including the three-way combinations of all variables, is analyzed. Clicking on OK here will take you back to the previous screen. Clicking on OK in the main dialog box will generate the analysis of your factorial screening. Click Next to continue. The DOE analysis uses the hypothesis test to determine the significance of each factor and interactions between and among factors. As you have seen previously, the p-value is a test of significance. In this case, a p-value of less than 0.05 means that the corresponding term is a vital X. Of the three main effects, the application type and field highlighting show a p less than 0.05 and are therefore considered vital X's. The font size is not a vital X. The combination of application type and field highlighting is also a vital X, but none of the other interactions qualify. So, our conclusion from this analysis is that application type, field highlighting, and the interaction of application type and field highlighting are the vital X's. Interactions are a critical concept here. Click Next to see a simple example. The combination of time and temperature in cooking is a good example of an interaction. If we have a specific temperature set, it will take a certain amount of time to properly cook an egg. Therefore, the time required, in this case, is dependent upon the temperature used. If we raise the temperature, it takes less time. If we decide to leave the eggs cooking longer, we must reduce the temperature. Neither factor can be optimized without taking into account the other. Click Next to continue. A common practice is to rerun the analysis, removing the term with the highest p-value each time, until the results are only those terms with a p-value of less than 0.05. In this case, we have gone back to the Terms box and removed all of the terms which include item A, the font size. Click Next to see the results.